A giant stone calendar stands silent on the Salisbury Plain. For centuries we understood Stonehenge as a place of memory or a ceremonial space. But what if its true purpose was far more advanced? This video will show you exactly how to read the astronomical patterns hidden within its iconic stones. You will learn to see this ancient monument not as a mystery, but as a sophisticated prehistoric timekeeping machine. We will uncover how its builders followed the sun and moon with remarkable precision, and why they went to such incredible lengths to capture the sky in stone. How does a community without writing engineer a legacy that lasts 5,000 years? 5,000 years ago, Britain was a land in transformation. Forests were being cleared for the first farms, and small, scattered groups were growing into larger, more interconnected communities. This was not a world of isolated hunter-gatherers, but a society on the cusp of something new. Across the landscape, people were beginning to work together on a scale never before seen, moving earth and raising great circular enclosures known as henges from timber and soil. This was a monumental revolution, a profound shift in how people related to each other and to the world around them. These structures were far more than simple buildings. They were the centerpieces of community life, serving as meeting places, ceremonial grounds, and physical anchors for a shared identity. Building them required something extraordinary, a collective vision that could unite hundreds of people in a single, demanding project that might not be finished in their own lifetimes. It was within this fertile ground of social and spiritual innovation that the first ideas for Stonehenge took root. The ambition to build in stone, a material meant to last for eternity, points to a society with a deep, stable understanding of its place in the cosmos. They were not just building for themselves, but for the generations that would follow. This foundational era, with its emerging class of skilled artisans and its networks for transporting precious materials over vast distances, created the perfect conditions for a project of staggering precision. The stage was now set for a leap in engineering and astronomical observation that would literally be set in stone. The sheer scale of this stone circle is almost beyond comprehension. Each of the massive Sarsen stones weighs as much as 25 adult elephants, an immense burden hauled over 20 miles across rugged terrain. But the true marvel is not just their transport, it is their transformation. These rough-hewn monoliths were meticulously shaped by teams of skilled workers using nothing but stone hammers and incredible dedication. They were not simply stood up, they were engineered. The tops of the upright stones were carved with rounded tenons, and the massive lintels that bridged them were hollowed with perfectly matching sockets, a technique known as mortise and tenon joining. This is the kind of precision work you would expect in a master carpenter's workshop, not in a ring of giant stones. The result was not just a monument, but a structure of incredible stability, a continuous circle of stone locked together against the centuries. Why did they go to such extraordinary lengths? Why was this perfect symmetry so vital? The answer lies in the need for absolute precision. A structure that shifted or settled would be useless for the task experts believe it was built for. This rigid, unchanging ring provided a fixed frame, a permanent set of reference points against which the subtle dances of the sun and moon could be measured. It was the foundation of a celestial clock, its perfect symmetry allowing it to function as a stable backdrop for the moving lights in the sky. With this architectural masterpiece complete, the builders could finally turn their attention to the heavens, aligning their stone circle with the cosmos itself. Every year, thousands of people stand in the pre-dawn chill, their eyes fixed on the horizon beyond the great stones. As the first sliver of sun breaks the skyline, a collective gasp often ripples through the crowd. The rising sun appears to perch perfectly atop the distant heel stone, its light flooding directly through the entrance and into the heart of the circle. This breathtaking moment is not a fortunate coincidence. It is the result of meticulous planning and profound astronomical knowledge, an event that has repeated itself for millennia. This is the summer solstice sunrise, the day the sun reaches its highest and northernmost point in the sky. The entire layout of Stonehenge is precisely oriented to capture this single, fleeting event. From the center of the circle, an observer looking northeast through the entrance sees the sun rise directly in line with the heel stone. This alignment forms the primary axis of the entire monument, a line in the landscape that connects human ritual directly to the cosmic cycle. Think of it as the giant hand of a cosmic clock, pointing to a specific date that marks the turning of the year. For an ancient society, this was far more than a beautiful spectacle. It was a critical anchor point, a fixed and undeniable fact in the cyclical flow of time. The solstice was a powerful public confirmation that their calendar was correct. After a year of tracking the more complex and variable movements of the moon, the sun would return to this exact spot, resetting the count and verifying their calculations. It linked their world of stone directly to the unshakable order of the heavens. Yet this solar anchor was only one part of a much grander design, a system that also had to account for the far more elusive and mysterious dance of the moon. But the sun's reliable path was only half the story. To truly master time, the builders of Stonehenge had to engage with a far more subtle celestial partner, the moon. While the sun follows a steady yearly rhythm, the moon moves to a complex 18.6-year pattern. Capturing this lunar cycle required a different kind of insight, one built into 4 smaller stones known as the station stones. These stones formed a precise rectangle around the main circle, a layout that has long intrigued researchers. Their purpose connects not to the sun, but to the moon's most distant movements. Every 18.6 years, the moon reaches what is called a major standstill, rising and setting at its farthest possible points along the horizon, well beyond the sun's yearly path. The corners of the station stone rectangle align perfectly with these outer lunar positions. Think of it as a giant, permanent frame in the landscape, marking the full scope of the moon's long-term journey. This was not an insight gained in one lifetime. Following this cycle required patient observations shared across generations, a collective effort of watching and remembering that points to a deep, lasting dedication to reading the sky. For a community living in close relationship with the natural world, anticipating these lunar milestones would have carried great meaning. It might have guided the timing of important gatherings, helped people prepare for seasonal shifts, or even shaped an awareness of coastal rhythms for those near the sea. By weaving the moon's intricate cycle together with the sun's dependable year, the architects of Stonehenge were crafting something extraordinary, a lunisolar calendar. This framework brought the lunar month, which is about 29.5 days, into harmony with the 365-day solar year. It reflects a profound, layered grasp of time itself, where 2 different celestial rhythms were synchronized within one magnificent stone creation. Yet the most intriguing astronomical secret might lie hidden beneath your feet. Scattered in a wide circle just inside the earthwork bank are 56 mysterious pits, filled with chalk and known as the Aubrey holes. For centuries, these were seen as simple post holes or perhaps symbolic places of remembrance, but a revolutionary idea emerged in the 1960s, suggesting these pits were the key to an ancient calculating machine. The astronomer Gerald Hawkins proposed a fascinating theory. Imagine placing small stones as markers in these 56 holes. By moving these markers from one hole to the next in a fixed pattern, you could mathematically track the complex rhythms of the sun and moon. This system, a kind of celestial abacus, could account for the subtle differences between the solar year and the lunar month. Its most stunning application, however, was the potential to predict eclipses. In a world governed by the sky, an eclipse was a moment of profound significance. The sudden darkening of the sun or the moon would have been an awesome and deeply meaningful event. The ability to foresee such a powerful celestial occurrence, to know it was coming when to everyone else it seemed a mysterious act of nature, would have granted the monument's keepers great influence. This was not merely about marking time, it was about understanding it, about turning cosmic uncertainty into predictable order. While scholars still debate this specific use for the Aubrey holes, the theory fundamentally shifts our perspective. It suggests Stonehenge was not a passive calendar but an active computational device, a Neolithic computer built from earth and stone. This idea of a built machine for tracking time forces us to ask a more basic question. What were the fundamental units of measurement that made such precise calculation possible? Deep within the protective ring of the Sarsen circle stands a structure of even greater presence. 5 colossal trilithons, each a pair of massive uprights capped by a single, towering lintel, are arranged in a graceful horseshoe. These are the giants of Stonehenge, built from the most immense stones and placed at the very heart of the monument. This was a clear architectural statement. The builders were creating a hierarchy of space, directing attention inward toward this most significant formation. The sheer scale of these trilithons suggests they were not merely decorative, they framed something of deep importance. The narrow gaps between these stone giants functioned like precision-made windows, carving the horizon into specific, narrow slices of sky. While the outer circle captured the grand solstice sunrises, these inner frames may have targeted more subtle celestial events. Some researchers suggest these windows could have tracked the rising or setting of particularly bright stars, or even the slow wanderings of planets, adding another layer of complexity to the monument's function. Each gap perfectly aligned would have highlighted a different point in the yearly cycle, effectively dividing the year into distinct, meaningful chapters. Imagine standing in the center as a specific star appears precisely in the slot between 2 trilithons. That single, predictable event would signal that it was time for a specific gathering, a seasonal observance, or a critical turning point in the agricultural year, like the beginning of harvest or the arrival of winter rain. The Trilithon horseshoe transformed the center of Stonehenge into a symbolic stage where the most significant cosmic moments were dramatically unveiled. This inner system did not work in isolation. It was the brilliant core of an integrated machine, a device that blended architecture with astronomy so seamlessly that the stones themselves seemed to breathe with the rhythm of the sky. Lying flat near the entrance is a great recumbent sarsen known as the slaughter stone, a name that suggests ideas quite different from its actual role. This stone was almost certainly another upright, a key part of the monument's grand design that has simply fallen. Its position is not accidental. It lies along the same primary axis that captures the solstice sunrise, acting as a foundational anchor point for the entire geometric layout. This becomes truly fascinating when you consider its relationship with the 4 station stones. These stones form a near-perfect rectangle around the central Sarsen circle, and the lines drawn between them create precise diagonals that cross at the very center of the monument. This is not rough estimation, this is sophisticated geometry etched into the landscape. The diagonals of this rectangle align with the most extreme rising and setting points of the sun at the midwinter and midsummer solstices. Think of it as a giant, permanent diamond shape superimposed over the circle, its corners and lines locking the movements of the sun and moon into a single, unified mathematical scheme. The fallen stone was a critical point in this scheme, helping to define this larger, invisible shape that gave the entire site its structural and celestial coherence. To achieve this on such a scale required more than just intuition. It points to a developed knowledge of practical surveying, an understanding of how to create right angles and measure long distances with simple tools like ropes and stakes. This intricate web of relationships, where every stone has a potential connection to another, reveals a blueprint of astonishing clarity. The vision for Stonehenge was fully formed in the minds of its architects long before the first stone was ever raised. This was not a project that evolved haphazardly over centuries, but the execution of a single, brilliant master plan, a plan that could only have been realized by a culture with knowledge carefully preserved and passed down from one generation of builders to the next. The stones themselves are a testament to immense physical effort, but the real genius lies in the minds that directed that labor. These were not people with metal tools or complex machinery, yet they solved engineering challenges that would still be formidable today. Their toolkit was simple but brilliantly applied. To dig the deep foundation trenches for the stones, they used picks made from the strong, resilient antlers of red deer. To pound the rough Sarsen boulders into smooth, precise shapes, they wielded heavy stone mauls, patiently grinding away for countless hours. To move stones weighing dozens of tons, they likely employed a system of wooden sledges, rollers made from felled trees, and ropes crafted from plant fibers, all powered by coordinated teams of people pulling in unison. The most delicate operation, raising a multi-ton stone into an upright position, was a masterpiece of practical physics. They would have dug a sloped pit at the end of a prepared trench, carefully maneuvering the stone over the hole. Using wooden levers and a complex arrangement of ropes, teams would then slowly pull the stone upward, packing the base of the pit with logs and stones to hold it in place until it stood vertical. This was not guesswork, it was applied engineering on a colossal scale. Such a feat required more than just strong backs. It demanded a sophisticated understanding of logistics, leverage, and communal organization. It speaks of a society capable of planning projects that spanned generations, of feeding and housing a large workforce, and of transferring intricate technical knowledge from one group of builders to the next. Yet this physical mastery was only half of their achievement. Parallel to this engineering knowledge ran an equally profound intellectual tradition, a deep understanding of the sky built through patient, cumulative observation. Without a written language or our modern mathematical concepts, how did they track the slow 18.6-year cycle of the moon? The answer lies in a different kind of intelligence, one rooted in pattern recognition. Imagine a small notch carved into a piece of wood or a stone, made each time the moon reached a certain point on the horizon. Over years and then decades, these simple marks would begin to reveal a repeating sequence. One generation would pass this accumulating record to the next, refining the pattern until the rhythm of the cosmos became as predictable as the changing seasons. This empirical knowledge, gained through centuries of watching and remembering, allowed them to encode celestial time into the very geometry of their monument. The true wonder of Stonehenge is this powerful fusion, the marriage of immense physical effort with a refined, almost spiritual, comprehension of the universe. The great Sarsen stones form the monument's powerful skeleton, but its heart may lie with the smaller, distinctive Bluestones. These rocks tell a story of an epic journey, for they were brought to Salisbury Plain from the Preseli Hills in Wales, a distance of over 140 miles. This was not a simple matter of finding the nearest quarry. Transporting each multi-ton block across rugged terrain, over rivers, and potentially even part of the sea would have been a monumental undertaking in its own right. The sheer scale of this effort suggests these stones were far more than just convenient building material. They were chosen, their origin was essential. Some theories propose these bluestones were believed to hold special properties, perhaps connected to well-being or ceremonial practices, making their presence vital for the site's spiritual power. Yet there is another compelling possibility. The specific geological makeup of these stones, formed in that unique Welsh landscape, might have been integral to the calendar's function itself. Perhaps their crystalline structure reflected moonlight in a particular way, or their origin was tied to a specific star or lunar event only observable from those western hills. Their careful placement within the grand Sarsen circle adds a profound layer of meaning. Imagine the bluestones as active components within the larger machine, their distinct composition or symbolic value connecting the cosmic cycles marked at Stonehenge directly to a distant, sacred landscape. This was more than architecture, it was a form of territorial and cosmic mapping. The immense labor required to bring them to the plain underscores one undeniable fact: they were absolutely indispensable to the monument's ultimate purpose. This connection hints at a vast network of shared knowledge and belief, a cultural vision that reached across the breadth of the land, binding distant places into a single, unified understanding of the heavens and the earth. The number 56 is not a random choice. It emerges from a deep mathematical problem that all ancient calendar makers had to solve. A year based only on the moon, with 12 cycles of roughly 29.5 days, gives you only 354 days. That is 11 days shorter than the true solar year of 365.25 days. If you simply followed the moon, your seasons would drift dramatically, with summer festivals eventually occurring in the winter. To keep the moon's months in step with the sun's year, you need a way to add extra time, a process known as intercalation. This is where the number 56 performs a kind of magic. It represents a grand cycle where the sun and moon finally return to harmony. Within a span of 56 years, you can insert just the right number of extra lunar months, specifically 21 of them, to correct the drift and resynchronize the two cycles. The Aubrey holes provided a physical, durable way to track this long count across generations. Picture a small stone marker moved from one hole to the next each year. After 19 years, you would add an extra month. The keeper of the calendar would know this because the marker's position in the sequence would signal the time for this critical adjustment. This system transformed the monument into a dynamic computer, its function evolving from simply marking a single sunrise to actively managing a complex, long-term calendar. It was a forward-thinking solution to a problem that spans human lifetimes, ensuring that sacred ceremonies and vital agricultural rhythms remained locked to the true turning of the heavens. But what if the grand solstice alignment was merely the anchor for a much more intricate and practical timekeeping system? Another compelling theory suggests that Stonehenge also encoded a solar year divided into 16 equal parts. Imagine a calendar not of 12 months, but of 16 distinct periods, each lasting roughly 22 or 23 days. This would create a rhythm of time perfectly suited to the needs of an agricultural society, providing far more frequent and precise markers for the turning of the seasons. The 30 uprights of the Sarsen circle, combined with the lintels resting atop them, may have served as the physical counters for this system. If you move a marker from one stone to the next, you could track these shorter, more manageable units of time. This framework would have highlighted not only the solstices and equinoxes, but also the cross-quarter days, the points midway between them that marked the true heart of the agricultural year. These were the days for planting the first seeds, for beginning the harvest, for moving livestock to new pastures, and for preparing for the deep winter. A 16-month calendar transforms Stonehenge from a monument that merely observed the sky into a tool that directly guided the essential tasks of survival. It connects the cosmic cycles above to the earthy reality of planting and harvest below. This was a living calendar, its stones ticking off the weeks and months that dictated when to sow, when to reap, and when to gather. The true genius of this system is its profound practicality. It wove the passage of time directly into the rhythm of daily life, ensuring the community's prosperity was synchronized with the unwavering clockwork of the heavens. The heel stone stands alone, an unshaped and weathered sentinel set apart from the perfect geometry of the main circle. Its rough, asymmetrical form is a clear contrast to the smoothly finished Sarsens, a deliberate choice that suggests a unique purpose. While it beautifully frames the midsummer sunrise, its role was likely far more dynamic than a simple annual marker. Think of it not as a fixed post, but as the central feature of a giant sundial. On the solstice, its shadow would be at its shortest, but as the year progressed, that shadow would grow longer and sweep across the interior of the monument. Could its extended shadow have been designed to reach specific stones or align with certain openings on important dates throughout the year, marking the cross-quarter days that were so essential to the agricultural cycle? This would turn the entire space into an interactive solar calendar. Furthermore, from the center of the circle, an observer could have used the irregular top of the heel stone as a precise foresight. By lining up its distinctive shape with the horizon or with other stones, one could follow the sun's gradual journey north and south, day by day, long before and after the solstice itself. This solitary stone becomes an active instrument, its very imperfection offering the detailed reference points needed for careful timekeeping. Its position outside the circle was not an afterthought, but the key to its function, allowing its shadow and its silhouette to interact with the inner architecture. This points to a system of telling time that was both grand in scale and intricate in its daily use, a system where a single, rugged stone held the ability to map the sun's endless journey across the sky. This ceremonial pathway, known as the Avenue, stretches for nearly 2 miles from the banks of the river Avon. It is far more than a simple track. It is a carefully engineered corridor that mirrors the primary solstice axis of the stone circle itself. Think of this as the final, crucial component of the calendar machine, a processional route that physically connected the life-giving waters of the river to the cosmic power of the stones. To walk this path was to enact a symbolic journey, moving from the everyday world of sustenance and flow toward the sacred center where time itself was measured. On the morning of the summer solstice, a procession moving up this avenue would have experienced a breathtaking spectacle. The path itself, defined by its low parallel banks, would have perfectly framed the rising sun as it crested the horizon directly ahead, aligned with the distant heel stone. This was not a passive observation, it was a full-body, communal experience of the celestial event. The architecture of the landscape was designed to guide your feet, direct your eyes, and focus your entire being on that single, transformative moment when the sun returned to its northernmost point. This integration of movement and astronomy transformed the calendar from an abstract calculation into a lived, emotional reality for the entire community. It wove the cosmic cycle directly into the rhythm of ritual, making the turning of the year something you did, not just something you noted. The avenue extended the monument's reach deep into the surrounding countryside, proving that the calendar was not confined to the circle of stones, but was a dynamic force that engaged the entire world. This drive to map the heavens was not unique to the Salisbury Plain. Across the ancient world, from the jungles of Central America to the deserts of Egypt, other cultures were engaged in the very same quest, building their own magnificent timekeeping machines. The great Mayan astronomers, for instance, developed the intricate long-count calendar, a system so precise it tracked vast cycles of time spanning thousands of years. They built towering pyramids that served as astronomical platforms, their steps and alignments marking the sun's path with a clarity that rivals any modern observatory. Far to the east, the Egyptians perfected a solar calendar of 365 days, a civil framework that governed the rhythm of their society and the flooding of the life-giving Nile. And in the heart of Europe, the Nebra sky disk from Germany, crafted from bronze and gold, presents a portable, symbolic map of the sky, capturing the sun, the moon, and the Pleiades star cluster. What is truly remarkable is the common thread connecting these distant innovations. Each one reveals a profound focus on solstices, a need to reconcile the lunar month with the solar year, and a desire to express this cosmic understanding through monumental art and architecture. They all represent humanity's shared aspiration to find order in the cosmos. Yet Stonehenge offers a solution that is distinctly its own. While the Mayan system was deeply mathematical and the Egyptian calendar was administrative, the genius of Stonehenge lies in its physical, interactive nature. The potential 56-year cycle of the Aubrey holes and the epic journey of the Welsh Bluestones have no direct parallel elsewhere. This was not a calendar recorded on papyrus or a codex, but one computed by moving stones in a circle of chalk pits, its very components fused with the symbolic power of a distant landscape. It stands as a powerful, uniquely European testament to ancient wisdom, a machine built not from abstractions, but from the earth and sky themselves, designed to be operated by a community in rhythm with the world around them. Behind the stones stood the people who gave them meaning. The sophisticated knowledge required to design and operate this celestial machine points to a specialized group within that early society, individuals who dedicated their entire lives to watching the sky. These were the Astronomer Priests, the keepers of the calendar. Their role was not just to observe, but to interpret, transforming the raw data of the heavens into a practical guide for their community. This was a lifelong pursuit, demanding years of training to master the complex patterns of the sun and moon, patterns they encoded into the very landscape. This hard-won knowledge granted them a profound form of authority. Imagine the power of being able to stand before the community and announce the exact day for planting, the precise time for a great ceremonial gathering, or even the approach of a significant lunar event. This was not magic, but a science so advanced it appeared as such to the uninitiated. It was the power to bring order from chaos, to synchronize human activity with the unshakable rhythm of the cosmos. This authority translated directly into social cohesion. The very construction of Stonehenge is a testament to a society capable of immense, coordinated effort over generations. Such a project could not happen without a clear, respected leadership guiding the vision. The Astronomer Priests were likely the architects of that vision, the ones who planned the alignments and directed the labor. Their calendar was the ultimate tool of organization, dictating not only when to celebrate, but when to build, when to harvest, and when to prepare for the changing seasons. In this way, the stone circle was far more than a timekeeping device. It was the very engine of social order, its silent stones speaking the language of a unified and purposeful community. Without a single written word, this knowledge had to live in the minds of the people. The intricate cycles of the sun and moon were not stored in books, but in stories, in chants, and in the very rhythm of ceremonial life. Oral tradition was the living library of this ancient world. Complex astronomical data was likely woven into memorable narratives, perhaps tales of a sky hero whose journey mirrored the sun's yearly path, or songs whose verses counted the days between lunar phases. These were not just entertainments, they were sophisticated mnemonic devices, turning abstract numbers into a vibrant oral culture that could be faithfully passed from elder to child. The monument itself was the ultimate teaching tool. The very process of building Stonehenge, of hauling a Sarsen stone into its precise position, was a physical lesson in alignment that an entire generation would never forget. Maintaining the site, clearing the sight lines to the horizon, and even the simple act of moving a marker from one Aubrey hole to the next each year, these repetitive actions trained the body to remember what the mind had to hold. The stones provided the unchanging reference points, the permanent lines on a grand communal syllabus. A keeper of the calendar could walk a young apprentice through the circle, pointing to a specific gap between the trilithons and saying, "When that star appears there, we begin the harvest." This was knowledge you could see and touch. This robust system of embodied learning, where ritual reinforced memory and the landscape itself held the answers, created an unbroken chain of understanding. The people became the living memory of the stones, their voices and their actions ensuring that the celestial clock kept ticking for century after century, preserving a cultural wisdom as durable as the Sarsens themselves. This scientific detective work has a name: Archaeoastronomy. It is the powerful fusion of two disciplines where the careful excavation of the past meets the precise calculations of the cosmos. Researchers in this field do not simply gaze at the stones and guess. They use sophisticated surveying tools to measure alignments with an accuracy of a fraction of a degree. They run complex software that can roll back the sky, simulating the exact positions of stars and planets as they would have appeared 5,000 years ago. Then they cross-reference these celestial maps with the physical evidence uncovered by archaeologists, from tool fragments to traces of early community gatherings, building a complete picture of how the site was used. This rigorous methodology has transformed the study of Stonehenge. What was once a subject for romantic speculation is now a field of testable, provable hypotheses. We can now say with confidence that a certain alignment was intentional because the geometry of the monument and the recovered artifacts from that specific sightline confirm its importance. Yet this scientific lens also reveals significant challenges. The Earth wobbles very slowly on its axis over a cycle of 26,000 years, a phenomenon known as the precession of the equinoxes. This means the stars that were brilliant markers in the night sky for the builders of Stonehenge have gradually drifted from their original positions. A star that once rose directly over the heel stone might now appear noticeably off to the side. Another persistent challenge is avoiding the temptation to see these ancient minds as simply primitive versions of our own. We must be careful not to impose our modern, scientific worldview onto a culture that likely understood the cosmos through a blend of precise observation, ritual practice, and profound mythology. The true goal of archaeoastronomy is not to prove they were like us, but to understand how they, in their own unique way, successfully built a machine that could read the sky. This disciplined approach provides the essential toolkit for putting the grand calendar theory to its ultimate test. Yet for all its compelling logic, the grand calendar theory is not without its serious critics. A persistent challenge from some archaeologists is the specter of coincidence. With so many stones placed across such a wide area, they argue, is it not statistically likely that a few will accidentally line up with significant solar or lunar positions? This human tendency to see meaningful patterns in random data even has a name: patternicity. When we look at Stonehenge with our modern, scientific minds, we may be connecting dots that its builders never intended to link. The most straightforward alignment, the summer solstice sunrise, is widely accepted as intentional, It is too precise, too central to the monument's axis to be dismissed as chance. But the case becomes more difficult when we move to the more complex proposed functions. Take the 56 Aubrey holes and their suggested role in tracking a long-term eclipse cycle. While the mathematics is elegant, no physical evidence has been found to confirm that markers were ever actually moved between these pits in such a calculated way. It remains a brilliant and plausible hypothesis, but one still in search of definitive proof. For these skeptics, the primary purpose of Stonehenge lay elsewhere. They point to the many personal objects and traces of early communities found at the site, suggesting its main role was as a vast ceremonial space, a symbolic place for important gatherings or a center for rituals honoring those who came before. Other theories propose it was a powerful territorial marker, a symbol of unity and control for the people that built it, or even a destination for those seeking well-being, drawn by the perceived special qualities of the Bluestones. From this perspective, any astronomical function was not the main event, but a secondary layer of symbolic meaning, a way of connecting those core human activities of memory, power, and health to the broader cosmos. Engaging with these criticisms is not a weakness in the theory, but a vital part of the scientific process. It forces us to continually question our assumptions and demand robust evidence. This dynamic, ongoing debate is a sign of a healthy field, where a monument of such profound complexity rightly resists any single, simple explanation. The true story of Stonehenge lies not in choosing one theory and ignoring the rest, but in understanding how all these potential functions, from the commemorative to the astronomical, might have woven together into a single, multifaceted tapestry of belief and purpose. The silent stones are finally beginning to speak, their secrets coaxed out by the gentle touch of laser light. Advanced technology is now our greatest ally in this ancient investigation, allowing us to see the monument and its entire landscape in ways the naked eye never could. Light detection and ranging acts like a cosmic paintbrush, digitally clearing away layers of vegetation and soil from the aerial view of Salisbury Plain. What has emerged from this digital sweep is nothing short of revolutionary. Stonehenge was not an isolated masterpiece, but the brilliant centerpiece of a vast ceremonial complex. The resulting maps reveal a sprawling network of processional avenues, smaller satellite shrines, and numerous memorial mounds, all carefully arranged around the main circle. This was a ritual landscape, a sacred geography where every path and structure was intentionally placed in relation to the cosmic clock at its heart. The journey to mark time was a physical one, moving through a terrain meticulously engineered to guide the traveler toward moments of celestial significance. Beyond the broader landscape, this technological lens focuses directly on the stones themselves. High-resolution, three-dimensional laser scanning projects millions of points of light onto every inch of the Sarsen surfaces, mapping their contours with incredible precision. This process has revealed a gallery of ancient art and subtle clues that centuries of weathering had rendered invisible to the human eye. Most famously, these scans confirmed the presence of 71 additional carvings of Bronze Age axe heads and a single dagger on the stones, symbols whose meaning is still debated. More subtly, the scans can detect patterns of differential weathering. Imagine one side of a stone is slightly more eroded than another, worn down over millennia by wind and rain. This could indicate its original orientation, or perhaps which face was meant to be observed during a specific ceremony or alignment, providing a quiet testament to how the structure was used and perceived. Perhaps the most exciting discoveries are the ones happening completely out of sight. Ground-penetrating radar sends pulses of energy deep into the earth, painting a picture of what lies beneath without ever turning a shovel. This non-invasive technique has uncovered a hidden world below the grass, a ghost image of Stonehenge's past. It has located a ring of buried pits, some massive, that may have held great timber posts or even smaller stones, forming an earlier, larger version of the monument. These phantom structures could represent the blueprint for the calendar, the very first attempts to map the heavens on this site. Each newly discovered post hole is a potential data point in a prehistoric equation, a clue to how the design evolved over generations. This unseen evidence is crucial, as it allows researchers to test the calendar theory against the monument's entire life story, not just its final stone phase. These tools collectively act as a digital time machine, peeling back the centuries with a gentle, respectful hand. They provide a flood of new, objective data that both confirms and complicates our understanding. A revealed pathway might perfectly align with a solstice sunset, strengthening the astronomical argument. Simultaneously, a located pit might sit in a spot that does not fit any known celestial pattern, challenging us to think more broadly about the site's other potential uses for ceremony or remembrance. This is not about replacing old theories with new ones, but about building a richer, more nuanced, and ultimately more human story. Technology is giving us the ability to listen to the whispers of the past, transforming a static ring of stones into a dynamic, living landscape once again. The stones did not merely track time, they sanctified it. For the people who raised them, the sun's yearly journey and the moon's monthly rhythm were not just celestial mechanics, they were the breathing patterns of a living, sacred universe. To observe the solstice was to witness a profound event, a moment when the veil between the human world and the cosmic order grew thin. The calendar was their spiritual bridge, a way to synchronize their community's heartbeat with the pulse of the greater cosmos. This was a relationship of deep reciprocity. A successful harvest or a thriving community was not just good fortune, it was a sign of cosmic harmony, a direct result of rituals performed at the correct celestial moment. The calendar guided when to offer gratitude for the sun's returning strength at midwinter, when to ask for the moon's blessing on new endeavors, and when to honor those who came before, whose memory now resides among the stars. These were not arbitrary dates, they were appointments with the sacred, essential for maintaining the balance of the world. This spiritual framework transformed the passage of time into a story of eternal return. The sun's apparent fading at the winter solstice, followed by its slow renewal, mirrored their deepest beliefs about life, transition, and regeneration. The moon's cycle from dark to full was a powerful, monthly drama of disappearance and renewal. By building a structure that could predict these cycles, they were not just forecasting the weather, they were demonstrating their faith in the universe's fundamental promise that life always follows moments of change. Stonehenge was the stage for this eternal drama, a temple where the community could actively participate in the great cycles of the cosmos. The act of moving a marker in an Aubrey hole was not a cold calculation. It was a ceremonial act, a prayer made physical. The gathering of people along the avenue at dawn was a collective reaffirmation of their place within a sacred order. This spiritual dimension is what elevates the monument from a clever tool to a place of unparalleled cultural power. The immense labor, the precise engineering, the epic journey for the Bluestones, all of it makes perfect sense when you understand that the builders were not just constructing a calendar. They were building a conduit, a permanent physical link between their world and the heavens. The stones anchored their rituals, their traditions, and their very identity to the unshakable certainty of the turning sky. In this sacred space, the measurement of time became an act of reverence, and the passage of the seasons was the most profound scripture ever written. The stones fell silent, but their influence echoed for centuries. Long after the last monument was raised on the plains of Britain, the deep, seasonal rhythms it once measured continue to shape the lives of those who came after. The great solar alignments, so central to the original calendar, appear to have woven themselves into the very fabric of later belief. Across the British Isles, from the Bronze Age through the Iron Age, we find a persistent cultural focus on the turning points of the year. The solstices and the cross-quarter days, those critical markers for planting and harvest, remained powerful anchors in time. The great ceremonial complex at Stonehenge may have been abandoned as a center of active astronomy, but it never lost its aura as a place of immense power. For the Celtic peoples who later inhabited the land, the site was likely integrated into their own rich mythology, perhaps seen as a dwelling of ancient gods or a gateway to the other world. The fundamental human need to mark the seasons, to celebrate the sun's return at midwinter and its peak at midsummer, did not vanish with its original builders. This knowledge, this connection to the land and sky, was simply translated into new languages of ritual and story. The very landscape around Stonehenge continued to be used for gatherings and memorials for generations, a testament to its enduring symbolic weight. Even as new peoples arrived, including the early Anglo-Saxons, the site commanded a kind of instinctive respect. They did not build upon it, but they often chose to honor their own important community members in the long barrows that dot the surrounding hills, as if to connect their own lineage to this ancient place of power. The original purpose of the celestial clock may have faded into legend, but the human impulse it served remained a timeless constant. The architect's greatest triumph was not just in building a machine to track the heavens, but in creating a permanent symbol for a universal human experience, our profound and unbreakable bond with the cycles of nature. This legacy invites a final, compelling question, one that brings our journey full circle. If this was the ultimate purpose of the monument, then what does its carefully engineered design reveal about the worldview of the people who conceived it? Even with all our modern tools and theories, Stonehenge stubbornly holds onto its deepest secrets. The grand calendar we have pieced together is a compelling model, yet crucial pieces of the puzzle remain just out of reach. We understand the principle of intercalation, the need to add extra months to sync the moon and sun, but the precise method the builders used is still unknown. Did they rely on a specific celestial trigger, a particular star's rising or a subtle shift in the moon's path, to know exactly when to insert that vital 13th month into their count? The elegant 56-year cycle of the Aubrey holes provides a beautiful mathematical framework, but the physical proof of its operation, the very markers moved from place to place, has eluded discovery. Beyond the sun and moon, other celestial bodies may have played a hidden role. Could the slow, wandering paths of planets like Venus or Jupiter have been tracked through the narrow windows of the great Trilithons? Are there alignments to specific, bright stars that we have not yet identified, their light long since shifted by the slow wobble of the Earth's axis over millennia? The significance of the Bluestones adds another layer of profound mystery. We know they were essential enough to warrant an epic journey from Wales, but their exact purpose within the calendar's mechanism is unclear. Were they arranged to mark a special lunar event only visible from their original homeland? Or did their unique composition interact with sunlight or moonlight in a way we can no longer perceive? Perhaps the most fundamental question of all concerns the location itself. Why here? What was so uniquely special about this particular patch of Salisbury Plain that it became the focal point for this colossal undertaking? The answer might lie in the very geology of the place, or in a confluence of ancient pathways that made it a natural center for gathering. It might have been a place of immense spiritual power long before the first stone was ever raised. Admitting these unknowns is not a failure of science, but a testament to the sophistication of the monument's original architects. Their system was so seamlessly integrated into their world that its full logic does not easily translate into our own. These enduring questions are not dead ends, they are the very engines of discovery, reminding us that this ancient calendar still has secrets to yield, ensuring its story is far from over. This stone calendar forces a profound re-evaluation of what we thought we knew about prehistoric minds. We are not looking at the work of simple farmers, but at intellectual architects who engaged in a form of abstract thought that rivals our own. To conceive of a 56-year cycle, you must be able to think in spans of time far beyond a single human life, planning for generations you will never meet. This is long-term thinking on a staggering scale. The very act of tracking the moon's 18.6-year rhythm required a sophisticated kind of memory, one that could record subtle patterns and pass that cumulative knowledge down through the ages without a single written word. Their numerical reasoning was equally advanced. The number 56 is not a random figure, it is a mathematical key, a solution to the complex problem of synchronizing the sun and the moon. This reveals a mind capable of seeing numerical relationships and applying them to solve a real-world question of immense importance. They were not just counting days, they were calculating cosmic harmony. This entire project speaks to a fundamental human drive, a deep-seated desire to find order in what might otherwise seem like a chaotic universe. By building a structure that could predict the solstice and potentially even eclipses, they were imposing a beautiful, predictable framework onto time itself. This completely transforms the outdated idea of the primitive savage, a notion that has long colored our view of early communities. The builders of Stonehenge were not our intellectual inferiors, they were our peers. They were simply using a different toolkit, one made of stone, memory, and an intimate connection to the sky, to answer the very same profound questions about time, existence, and our place in the cosmos that still captivate us today. Acknowledging this sophistication is not just about giving credit where it is due, it is about rewriting the human story. It pushes the timeline of complex intellectual achievement back thousands of years, forcing us to see the narrative of human progress not as a straight line from simple to complex, but as a tapestry of different cultures, each finding their own unique and brilliant ways to understand the world. The silent stones of Salisbury Plain stand as a permanent challenge to our modern assumptions, a powerful monument to the universal and timeless nature of human ingenuity. So the journey through this ancient calendar comes full circle, from the unmistakable solstice sunrise to the subtle 18-year dance of the moon. We have seen how a simple alignment with the sun may have blossomed into a sophisticated lunisolar calendar, a system capable of harmonizing the moon's months with the sun's year. We have explored the tantalizing possibility of the Aubrey holes as an early predictive tool for celestial events, and considered how the inner sanctum of the great Trilithons might have divided the year into practical, meaningful chapters. Yet the true story of Stonehenge cannot be confined to a single purpose. It was not solely a celestial clock, nor merely a temple, nor just a place of ancestral memory. Its profound power came from the fusion of all these roles into one. The calendar was the heartbeat that gave rhythm to its spiritual life and social order. The genius of its architects lies in that seamless integration where a single stone could simultaneously mark a solar position, frame a ceremonial procession, and embody a cultural memory. This multifaceted center was the engine of its society, a place made sacred by its connection to the cosmos, and in a remarkable testament to its enduring power, thousands of years later we still gather there. Every summer solstice, people stand in the pre-dawn chill, their eyes fixed on the same horizon, waiting for the same sun to crest above the heel stone. In that shared, breathless moment, the gulf of millennia vanishes. We are no longer modern observers analyzing an ancient puzzle. We are participants in the same eternal cycle, connected across time to the minds who first dared to capture the sky in stone. The calendar itself may have fallen silent, its precise mechanisms faded into the past, but its stones still speak a universal language of wonder, reminding us of our timeless human quest to find our place in the vast, ordered beauty of the universe. You can stand on the digital Salisbury Plain right now, using online tools to explore the monument's alignments from your own home. Or if you ever have the chance to visit in person, walk the avenue and watch for those key sightlines toward the heel stone. To dive deeper into this fascinating field, look for documentaries and books on archaeoastronomy, a science that brings ancient skies back to life. We would love to hear your perspective in the comments below. After this journey through the stones, which interpretation resonates most with you? Is it the grand celestial calendar, the ceremonial heart of a community, or perhaps another idea entirely? Ultimately, the quest to understand Stonehenge is about more than just solving an ancient puzzle. It is a powerful reminder of our shared human impulse to look up at the stars and find meaning, to mark our time under the sun and moon, and to build legacies that carry our questions into the future. That timeless drive to find our place in the universe is a story that began long before the first Sarsen was raised, and it is one we are all still writing today.